Before continuing on with trigonometric integration, I need to introduce cotangent, secant, and cosecant to you. So let's say we've got a circle of radius 1 for simplicity. We could use any radius, but let's choose 1 for simplicity. Let's say this angle here is x. We've seen that this opposite, the length here, is sine x, and the adjacent will be cos x. Now, tangent would be from here to here. Tangent would be opposite over adjacent. But going the other way, adjacent over opposite would be cotangent. So that's this thing here. So going the other way, it would be the adjacent, which is this thing here, divided by the opposite, which is this thing here. So cotangent is cos x over sine x. Normally this is cos. Normally this is cos of x. But going the other way would be secant of x, which is this thing here. So here you can see that the radius is 1. And then this adjacent here is cosine x. The length of that adjacent is cosine of x, which is this thing here. So secant is 1 over cos of x. And then normally this is sine. Well, going the other way would be cosecant. Well, going the other way would be the radius, which is 1, and the height here would be sine of x. So cosecant is given by this. So now we can start to make use of these three. Okay, so let's look at this. Hang on. You can let's differentiate this. Let's differentiate secant. So if you're asked to differentiate secant of x, you have no idea what this is. So just replace it with 1 over cos of x. So that's this thing here. Hang on. So remember, secant is this thing here. This is secant of x. This is cot, and this is cosecant of x. So really we can't differentiate any of these. So let's try and differentiate this one here. We don't really understand what secant of x is. So let's just replace it with 1 over cos. So we're trying to differentiate secant of x. At this stage we have no idea what it means, so let's replace it with 1 over cos of x. So now use the quotient rule. So v squared, if you're trying to differentiate u over v, if you're trying to differentiate this, then it would be v squared, so the denominator squared, that's this thing here, and then the v stays intact, differentiate the u. So well, if you differentiate the u, it will be nothing. So nothing times cos will be nothing. So this thing here would be nothing, and then you minus, and then it would be v prime u. Well, u here would be 1, and then v prime here would be the derivative of this, which is negative sign. And then you've got a negative and a negative that give you a positive. Well, differentiate this, that will then give you this thing here. And then break this fraction up as one block, multiply another block, because this times this will give you sine, this times this will give you cos squared. So break this fraction up as two fractions. Now 1 over cos, remember, is secant of x, because 1 over cos, secant of x is this thing here. So 1 over cos is secant of x. And then, hang on. So 1 over cos is secant of x. And then this thing here, sine. So if you have your unit circle, sine is the height here, divided by, well, this is 10 here. This is 10. So when you differentiate this, it will give you secant of x times tan of x. This is important, so write it down somewhere on a piece of paper. So when you differentiate this, it will be itself times 10. So now, if someone asks you, how do you integrate secant x tan x dx? Well, you can just work backwards and just say, oh, it's secant of x plus c. But don't worry about this. What's important is this thing here, because we're going to make use of this in the future. Okay.